It's 25th Feb. We are going to start with lesson 6.1, that is the new unit, populations and samples. Girls, like finally we are a little bit out of algebra, all that X, Y, and Z and numbers and letters, but we still will, yeah, we will face them, but not a lot. So first lesson here is population and sample. Let us see what we have here in this lesson. Okay, the unit here is, before I start with the lesson, let me say the unit's name. The unit name here is, what do you call as, use sampling to draw inferences about population. We need to, this is something like graph, girls. If there are very important topics I'm gonna do in this, or else I will quit many of them. Before I start with the lesson, I want to show you a small video. Please go to it. And go to
This topic focuses on extending students' understanding of how to display, describe, and summarize numerical data by introducing the concepts of populations and samples, showing students how to make inferences about a population using a sample, and how to informally compare two populations. Students review the concept of a population and then focus on how using a sample or subset of a population can yield information about the entire population, if the sample is randomly selected. They learned that a representative sample accurately reflects the characteristics of the entire population. In a random sample, each member of the population has an equal chance of being included. A random sample tends to be a representative sample. Students also learned that the best way to characterize a population is to generate a random sample in which each individual in the population has an equally likely chance of being selected for the sample. Students extend the concept of a random sample to understand that no two random samples will have all the same members, nor will their distributions necessarily look the same. However, if the samples are large enough, they will be representative of the population. In this example, we see that there are 20 members in each sample. The only numbers common to both samples are 38 and 106, and the numbers are distributed differently in each sample. During this topic, students get to review the shape of data displays and descriptive statistical measures such as mean, median, range, and interquartile range. They extend these concepts to draw informal conclusions or inferences by looking at the data and verifying whether the shape of the data and the statistical measures support these inferences. Students make both qualitative and quantitative inferences from a single data set and form two data sets based on two random samples. Students are able to combine their previous knowledge of ratios and proportional reasoning with their knowledge of drawing inferences about a population to make predictions about the population. Essentially, they will be calculating a metric for the part or sample and using it to make a prediction about the whole or population. For example, a random sample of 7th graders shows that 16 out of 20 have cell phones. If there are 290 7th graders in the school, estimate the number of 7th graders that have cell phones. Students can apply their knowledge of ratios and proportional reasoning to write and solve a proportion to estimate the number of 7th graders, or C, that have cell phones. The topic continues with students using different data displays and their appropriate measures of center and spread to compare samples and thus draw conclusions about a population. Students learn that measures of central tendency are useful in comparing populations, but that they will vary from sample to sample. So measures of spread will assist in validating these.
It's just like you all are listening to a lecture. Okay, so here, let us begin here. All right, girls. So please turn to page number 311. Turn to page number 311. Or 312. See, girls, here first let me do the example. You're not going to do it, I'm just explaining you, and then we'll do this try it. Okay. In 2000, the 2,468 registered voters in Morgantown are voting on whether to build a new stadium. All right. All our stories, please listen to them carefully. 2,468 people in this town, they're voting to build a new stadium or not. Morgan and her friends really want the town to vote in favor of the new stadium. How can they determine how the voters will vote before the day of the vote? Morgan and her friends could ask every registered voter or the entire of the voters in town how they plan to vote. However, surveying 2,468 people takes a long time. Morgan and her friends may not be able to survey the entire population. They are surveying how many people? 2,468 people. They went for a survey to see what are they voting and what are their plans. Now, Morgan and her friends could ask a subset of sample. They cannot go to so many people and ask that what are your plans? Are you giving the vote for us or not? So what they do is, dear, they select few random samples from these 2,468. They get a subset of a sample. Surveying a sample of voter does not take as long as it's more reasonable to do. Morgan and her friends would be able to ask 100 or 200 people. Among these so many 2,000 so much people, Morgan is just asking some random people, maybe 100 to 200. Next, Miguel thinks the science teacher in his school give more homework than the math teacher. Imagine you think your science teacher, you're lucky that you have both same teacher, science and math. So they're saying science teacher give more homework than math teachers. He's researching the number of hours middle school students in his school spending during math and science homework each night. Now, what includes all the students? When we say all the students, we say it as population. And if we say a possible, yani some students, girls, this word, very simple, there is nothing to solve here. Just use your logic. When you say all the students, you need to write population. And when you say some students, you need to write sample. Did you get it?
Yes.
That's it, girls.
Yeah.
Please write down page number.
Please what?
I'm going to say
312.
312.
I'm done.
Now, Ravi is running against two other candidates for student council president. Okay, he needs more two students for some student council president, and there are 750 students. Imagine, girls. Okay, for he can. How can Ravi generate a representative sample that will help him determine whether he will win the election or not? Ravi can assign each student in school a number and randomly select. First of all, he will give a number to each student, like you are 1, you are 2, you are 3. And he will randomly select numbers until he reaches the desired sample size. You need to write the sentence, girls, that he will assign each student in a school and then randomly select a sample. Please write this sentence. It's all about theory, girls. There's nothing solving questions in this lesson.
Okay.
And of course, these kind of lesson I won't include in the quiz to write down stories here. Done?
No.
No.
I'm done.
Others, did you finish?
No, miss, I'm in select. I'm done.
Okay. The table at the right shows the random sample that Jeremy's generated from the sample population and Morgan's and Maddie's. Compare Jeremy's sample to Morgan's uh, and Maddie. Okay, this is Jeremy's sample. Now, why did they choose here 125 and 36? Let us see. Jeremy's sample also has 20 members. Where is this Jeremy sample? See, we have Morgan's and Maddie sample girls here. Morgan and Margie. And here we have Jeremy's sample. Now, when I compare, Jeremy has also 20 members and the number 36 is also in Morgan's sample and the number 126. If we compare these three boxes, girls, here they have 106. One minute. We have to compare that what is common in that, girls. Even Morgan has 106 and even Maddie has 106. Even Morgan has 38 and Maddie has 38. Now let us compare to Jurgen's sample here. He has 126 and who has 126 here? Let us check. Oh, it's here. See? Even he has 126, Maddie, and even no, he doesn't have. So Maddie and Jurgen has common of 126. And then again, let me check what else is there. I think 36. 126 and 36. Let us see. Where do I get 36? You just have to see the common in the table. You have 126 here. Okay, let us search. There's no 36 in Maddie. In Morgan, it might be there. Check 36 girls, please. Why I cannot find 36?
Here, beside 91.
Yes. So, see, we are seeing comparing the Maddie sample with Jurgen sample, Morgan sample, and we see that 36 is in common with Morgan's and 126 is common with Maddie. That's all we have to
Miss,
know.
there is no 36.
It's 36 here.
Oh, miss, I didn't understand.
You are just checking what is common, sweetie.
Oh,
Maddie sample, what do you have same as the Jeremy sample? You have 126 and 126 here. You don't have any other number. If you check each and every number with this, you don't have any other number. And when you come to 36,
oh.
36 same exactly here 36. And other number, you cannot find it here.
Okay.
So that's what they say. Jeremy's sample also have 20 members. The number 36 is also in Morgan's sample. See, the number 36 is also in Morgan's sample and the number 126 is also in Maddie sample. There are no number common to all 3 student sample. Not even one number is there that is common in all the students. See, 126 is there in Maddie, but it is not in Morgan's. 36, understood? There's no number. There are no numbers common to all the 3 student sample. This is what you have to write. They are just
Right?
you to compare, girls. How are they randomly selecting and they are comparing that do they have common in the sample or not? Finished?
No. No. I'm done.
Okay, guys. A health club manager wants to determine whether the members would prefer a new sauna or a new steam room. The club surveys 50 out of its 600 women. Girls, when I say population, is it 50 or is it 600? When I say population, is it 50 or 600? What is the meaning of
600. So many.
population? Means all of them together. So all of them are 600. 50 are just selection. So what is your answer? The population is all 600 members. Girls, remember the word population means you need to say all of them. In that you can select, that is the random selection. 50 is the random selection. 600 is a population. Now, next question. A journalism teacher wants to determine whether his students would prefer to attend a national writing convention or tour of a local newspaper press. The journalism teacher has a total of 120 students in 4 different classes. 120 total students in 4 different classes. What would be the representative sample? Now, girls, first of all, teacher can put 120 students' name in a hat and then randomly select the names to a random sample. First, she will put in a hat or in a box and then she will select from them. That is called the representative sample. Representative sample means you have to put all of them together and then from them you need to select. That's what she will put the names of those students, all the students first in a hat. Hat means from where she has to pick up the chit or something. And then she will randomly select the names to create a random sample. A very, very simple lesson because there's nothing to not understand or simple. What is population and what is selection?
Yeah, very, very easy.
Very easy. There is nothing after such a long time you will relax.
I want all the lessons like this.
Mathematics is not that sweet, and it loves to be sometimes bitter and sour. That's the beauty of mathematics.
I'm done.
Okay, good. Now, question number 6. Garrett wants to find out which restaurant people think serves the best beef briskets in town. What is the population from which Garrett should find a sample? The population of the town, right? He can see the residents of the town, how many houses are there in the town, and he can get the population. And how will he know the sample? The customers at one of the restaurants that serves beef brisket. He will see the customers. How many customers are there? Those are the representatives. But all of the town is the population. Population means all of the town, that is the residents of the town. And sample
Yes.
means the customers only are the samples.
And then
Can you make it a little bit bigger?
What might be a sample that is not a representative? Okay, we have done this, right? Okay, now. Out of a group of 200 workers, 15 are chosen. Girls, by looking at it, total how many are there? 200. 200 is the population and 15 are the sample. That's it. In this situation, the sample is 15 and the population is 200. Miral, did you get this? Miral, Dana, I'm not even asking girls today because I feel that this is very simple. Did you
no,
all?
I understand.
The tickets manager for a minor league baseball team awarded prizes by drawing 4 numbers corresponding to the ticket stub numbers of 4 fans in attendance. In this situation, the sample is 4. The population is all of the spectators who purchase the tickets. Because we don't know the number all, so we just write all here. And we write because they said they draw 4 numbers. When you are drawing something, you know the meaning of drawing? It's not coloring. Drawing is you're picking up 4 chits. Question number 9. A supermarket conducts a survey to find the approximate number of its customers who like apple juice. What is the population of the survey? Okay. What is the population? All of the supermarket customers becomes the population here because we are only conducting a survey for customers, not anyone. Customers means those who come to the market. So when you see all the customers, that becomes the population of customers. Question 10, just put a cross mark. We'll do question 11. Of the 652 passengers on a cruise ship, 30 attended the magic show. What is the sample? 30. How many? That is magic show attendees. What is the population? Cruise ship, all of them. That is 652 passengers. Please write down. I don't know why did they not write. Just say all cruise ship passengers. All the cruise ship passengers.
And then
The owner of landscaping company, in investigating whether his 120 employees would prefer a water cooler or bottles. 120 employees is the population. The population consists of all the landscaping company's employees. A representative sample should consist of randomly selected employees. Again, it's not needed to write, girls. Leave it. So much, how can you write? Come to this question, next one. We'll do with question number 15. The table shows the result of survey conducted to choose a new mascot. Yolanda said that the sample consists of all. The sample is all 237 students. What was Yolanda's error? She identified 237 as a sample instead of the population because she had to see all the population, not only 237. And what is the sample size? 40 students. How did they get 40? By adding all of these, girls, by adding all of this. Because these were the samples chosen. So 24, I'll write down here, 24 plus 6, 30, 32, and 40. Sorry, 8. It is 40. Rest all the questions, leave it, girls. That's it for today's class. Any other questions you have?
No.
That's it for today's class, girls. We'll dive into lesson 2 tomorrow.